We are examining power in frequency domain. We already found one of the element, instantaneous power, average power, and reactive power. Now we will be examining different type of elements, average power and the reactive power. These different type of elements or circuits could be either resistive. So I am examining now this frame. Resistive circuits power, average power, reactive power. Inductive circuits power, once again, average and reactive power. Capacitive circuits, elements and circuits, average power, and the reactive power we will be examining step by step. So move to open board. Okay. Open board. Start with the resistive circuits power. So all we need the resistive element definition relation in frequency domain in terms of phasors. So it's going to be V over Ri. So V is the phasor, voltage phasor. I is the current phasor of a resistor. So V as a phasor is equal to Vm e to the power j theta V is equal to R times Im e to the power j theta I. Theta V is the angle of the phasor. Theta I is the angle of the current phasor. So if I move this one to the left hand side, so it's going to be Vm over Im e to the power j theta V minus theta I is equal R, isn't it? So this minus, why is that? If you put this in the numerator, move it to the denominator, so this comes to underneath here, denominator, so move it to the numerator, it's going to be minus. So since this is a real number, so this is a real part of my number, and that should be equal to 0. When this is equal to 0, then e to the power 0 is 1, so real number equal to a real number. So when the result is theta V minus theta I for the resistor is equal to 0. So that means the phase difference between the voltage and the current of a resistor is equal to 0. That's the conclusion. So that's that conclusion. I just find what it is. So our power, instantaneous power, was this. So in terms of the average power that is shown here is average. Average in terms of average power in instantaneous power is this. So the average power is this. Since we have found the phase difference between voltage and current is equal to 0, that's going to be 0. So cos 0 is equal to 1. So the average power is this for a resistor. The reactive power was this. Reactive power, and we show it as Q. Since this phase difference is equal to 0, sine 0 is equal to 0, so reactive power is 0. There is a conclusion now we can get out of this. What is that conclusion? Resistive element power is the maximum power. Since this cos is the maximum value that 1 here, that's the maximum power. That for the resistive elements or resistive networks, we know this, we get the maximum average power, useful power. Reactive power, on the other hand, is equal to 0. This is not a useful power. So that reactive power is 0 for the resistive circuits. So if we draw the instantaneous power for this case, so that's going to be 1. So that means that's going to be 1 plus, that is 1 once again, that is 1, and that's going to be 0. So let's make it a different color here. So for the instantaneous power, if we want to draw the instantaneous power, the coefficient Q is equal to 0, so that is going to disappear, and we're going to end up with this. And if I write this openly here, PT instantaneous power, 1 over 2 Vm Im cos theta v minus v is equal to 1, so I didn't write it, so plus 1 over 2 Vm Im cos 2 omega t. So if you put it in parentheses, it's going to be 1 over 2 Vm Im 1 plus cos 2 omega t. So if we assume that for a special case, to make it simple to draw it, this is equal to 1, so that's the instantaneous power. So you see that instantaneous power here, it is a cos 2 omega t function, is that blue function here, and you're going to add a constant to this one, so it's going to come on that. So that is the instantaneous power that we draw. This is cosine function. Why it is cosine? It starts with 1, isn't it? That one comes from that one here, plus this coefficient, the highest coefficient is going to be 1, so total is going to be 2. So it's going to be a cosine function like that. On top of that, DC value 1. So this is for the resistive circuits. Let's come to inductive circuits. When the circuit is inductive, definition relation is going to be like that. So that means this you can consider that module is Vm, isn't it? And this is Im. So is equal to the impedance of an inductor. The impedance of an inductor is equal to this one. So this is equal to this one. So real part is going to be equal to this real part, and this imaginary part is going to be 90 degree. So you might ask, why? How you found that 90 here? That e to the g 90 is replaced with that j. So j equal to this. Why is that? This is Euler formula, isn't it? E to the power j 90 is equal cos 90 plus j sin 90 degree. Cos 90 degree is equal to 0, sin 90 degree equal to 1, so e to the power j 90 is equal j, isn't it? So I replaced j with e to the power j 90. So in this case, this VL over IL, these are the phasors of inductor, is equal impedance of the inductor. Impedance of the inductor is equal to this, so this angle must be equal to each other. So conclusion, the phase difference between the voltage, phase difference for an inductor is 90 degree. That means phase difference between the voltage of current of an inductor is 90 degree. So if we apply it to our average power is this, isn't it? If this is 90 degree, that's going to be 0. So since this is 0, that's going to be 0. And this one is going to be 0. So this term is also 0. So this becomes instantaneous power in our case. So because this is 90 degree, that's going to be equal to 1. So Q, which is this, if we assume that 1 over 2 Vm Im is equal to 1, so it's going to be 1, isn't it? So that means reactive power is equal to 1 for an inductor. But average power is equal to 0. That's the average power. So that's the opposite of what we said for the resistor. We said average power is the maximum value, reactive power is equal to 0. In here, the reactive power is maximum value and the average power is equal to 0 for an inductor. So the Q equal to 1, that means that as a function this is going to be minus sin 2 omega t, under the condition that we are assuming this coefficient is equal to 1, that coefficient is equal to 1. So why we assume that? We said to draw it a simple drawing, I assume that that is equal to 1. So if it is different from 1, so you're going to put that value in. So in this case, it is going to be minus sin 2 omega 2. This is a sinusoidal function. That minus make the beginning minus. And it start from 0, so it start from the 0. The highest value that we can get is going to be plus minus 1, isn't it? So this is a sinusoidal function. The highest value you can get plus minus 1. So reactive power is equal to 1. That is the maximum value of this, isn't it? Minus, so it should have been here. Reactive power. Oh, reactive power is equal to 1, isn't it? So plus 1. If you put that value here, that function is going to be minus. So reactive power is equal to 1. So reactive power is equal to 1. That is the highest value of it, of this. So let's come to the last one, which is a capacitive circuits. So in this case, make a different color here. So this is the phasor of a capacitor, voltage phasor of a capacitor. That is the current phasor of a capacitor. So if I write it in polar format, it's going to be like that. So that VC is the maximum value of the voltage of a capacitor. That's the maximum value of a capacitor. That is the difference between the voltage and current of a capacitor. Time difference or phase difference. On the other hand, if I write the impedance of a capacitor, which is equal minus J1 over omega C, 1 over omega C, and that is, we are saying now, that is equal to minus J. It is easy to prove that. We know the Euler formula, minus J90 is equal cos 90 plus J sin minus 90 degree. Cos minus 90 degree is equal to 0. That is minus 1. So it is equal minus J. So this impedance is the ratio between the voltage phasor and the current phasor. So that means that is equal to this one. And if I separate, this is the real part of it, must be equal to this real part. And the phases R must be equal. So that means voltage and current phase difference for a capacitor is minus 90 degree. For the inductor, it was plus 90 degree. If it is minus 90 degree, then the average power becomes 0, because that is 90 degree minus 90 degree. That makes this 0. So this term disappears, this term disappears. And 90 degree here makes minus 90 degree here, minus 90, makes this one is equal minus 1, isn't it? So that means reactive power is minus 1. Reactive minus this part is minus 1. if we assume that this is not 2, this is just 1. If we assume that this coefficient is equal to 1, so our reactive power is minus 1. If we put the minus 1 here, it's going to be plus, isn't it? So this is plus sinusoidal function, which is over 0. Since it is minus 1, reactive power is minus 1 here. So that's the end of, that's the conclusion of it and end of this video.